Lab 1, Magnetism at Work for ELEC 1110. This is exercise 1, making your coil. You are going to want to go and cut yourself about a meter of conductor. A meter would be an average person's single wingspan. So center of your chest to one set of fingertips, that's about a meter. Another way of measuring it would be 3 squares on the floor. That would be about a meter worth of tiling on the floor. What our goal is to end up with a coil that looks like this. Now in the lab we do have a few extra medicine medicine cups that will help us to make this and make it a little bit more efficiently. Now in the end you are going to want to have 3 to 4 centimeters of stripped conductor on one end, or about 2 fingers, just a little bit less. So what we're going to want to do is keep a little bit of that free and exposed. Now what we can do is, while we are working around this cup, if you don't have cups, I've found that simply 2 fingers, if you have about 2 fingers, but you're going to end up wrapping it tight and it's very hard to get off later. So if you take about 2 fingers, make them just a little wider than 2 fingers, and you are going to wrap these up nice and snug. Now I see a lot of times where students will not make these very clean, and they make them very odd shapes for some reason. They are not nice and clean and round and nice and tightly wrapped. You want to make sure that you have nice even wraps. You don't want one loop that's way long. You want to have them nice and evenly spaced. If you need to use the medicine cups to do that, that is fine, but you want to make them nice and neat. This is going to help in the centrifugal forces when it's spinning later. Now with these extra tails here, we are going to want to wrap them just 2, maybe 3 times around the individual coils. Now if you end up with a very short piece like this, you are going to want to back up. You're likely going to want to give yourselves probably close to a full 4 fingers worth of conductor in order to do this. Now you're going to want that on both sides, so we're going to back another coil off of here as well, and we're going to wrap this up just to keep it contained. That ends up with your conductors off the other side, and when we come over here we want to do the same. Now my suggestion is to wrap this the opposite way of the other side, and the reason being is, if you wrap it in this method where both of these tails are coming off of one side, it's going to hang funny in the cradle that we're going to make in exercise 2. So my suggestion is to wrap these so that your tails are coming off opposite sides of the coil. It's going to make your lab just a little bit more efficient. This way you can see here that we have our coils coming off of opposite sides. We have our 3 wraps on that side and our 3 wraps on that side. Just going to make it a little bit easier for you to deal with. Now the excess is not a huge deal. We can simply trim that off, and you're going to also want to strip those conductors. And exercise 1 complete. Nice and round, and our cables are coming off of opposite sides to make our lab run just a little bit more efficient. Alright, so for exercise 2, you're going to want to build a little motor assembly cradle. You're going to end up getting a wood block with a rare earth magnet that is permanently glued or double-sided taped to this board, as well as 2 screws. You may or may not get your own copper cradles. However, depending on everybody's finger sizes or where you wind your coil on your cup, your coils may be different sizes. They may have different diameters, therefore your cradle will be a different height. What the goal is to get these to do is, you want to build a cradle that will allow your coils to sit just marginally off of that magnet. You don't want it too high, but you also don't want them touching. So you want them to be very close, but you do not need them touching. If they touch, it's not going to spin for lab 2 for you. Now, one of those things you can do is you can simply spread these out to get them to sit nice at the right height. If one needs to lean over or what have you, you need to form it so that it works by your coil. One of the other things that you want to attempt to do is you want to attempt to have them straight over this magnet. If you are able to get your coil to sit as vertical as possible, as centered as possible, as well as the stripped ends on your cradles, that is the goal. By leaving these a little bit longer initially when we did the exercise 1 building the coil, that will allow you to spread your cradle farther apart to allow you to get that up and down motion in that cradle. This is what we're shooting for in exercise 2. Alright, exercise 3, lab 1. Once you have your coil spinning nicely and you have your clearances all good on that, nice easy cradle setup on that, we are then going to set up our power supply. You are going to turn the power on. You're going to set this into parallel. You are going to start with your coarse voltage to 9 o'clock and your fine voltage to 12 o'clock. Start where they're current at the bottom. We can turn that off. We can then clip our alligator leads together, and we are going to set it to 1 amp. We are going to turn this up until we get approximately 1 amp going through this, right in around 1 amp. Plus or minus 0.2, 0.3 is not going to be hugely detrimental. Around 1 amp. We are then going to move down into our coil here, and if we hook our black line onto one side and we hook our red to the other, we simply tap it. For this one, you're going to want to try and have your, I have my power supply shut off right there, you're going to want to try and have your coil hanging as vertically as possible for this. Alright, you're going to want to get that sitting as straight up and down as you can over top of that. And power supply back on with our previous settings, and if we tap this to it, you'll notice that the coil has bounded in one direction. The bottom of the coil is going in that direction. That's pretty neat. Now, we are currently sitting at 1 amp, and our leads, look at those alligator clips, they're in pretty good shape, eh? We are sitting at 1 amp on our power supply, and if we go to touch it, you'll see that it goes a certain amount away from center. If we then take our clamp and we are simply going to short this out, we are going to hold that there, shorting our power supply out, and we are going to adjust this from 1 amp to 1.5 amps, give or take. Add half an amp to it. If you were already 1.3 previously, add another half an amp to it, 0.5 amps, and we can then see that if we take that same lead and we touch this side again, that we go marginally farther. We are just a little bit more swing away from that center line.